Hey everyone, and it's day 8 and we are still on same intensity to solve daily lead code problems. And our today's problem is basically dependent on binary search algorithm and it's one of its variation. So first we are going to understand what is binary search algorithm, and then we are going to understand how we can apply binary search algorithm on reverse, like array which is sorted in reverse order. So let's begin. So first of all, we have to learn what is binary search algorithm. Basically it is a searching algorithm that checks if any targeted value is available in our array or not. So first of all, to search any element through this algorithm, we are going to assign two pointers which are L and an R. L will be on the starting end of the array and R will be on the end of an array. And then we will be using this formula where we are going to calculate L plus R double divided by 2, which will give us the mid value of our array. So here our mid value is 5. So we will check our target. Let us suppose our target is 7. So if our m is smaller than like targeted value, yes, 5 is smaller than targeted value, then we will shift our left pointer to m plus 1, and then we will again calculate our m, and then it will be happening in loop iteration, or we can do it recursively also. So with that said, then our m will be calculated, then 6 plus 9 6 plus 9 should be like uh, 15 divided by 2 will be 7.5, and we are using double division sign, so it will be 7. So m will be 7, and then we will check if m is equal to target. Yes, m is equal to target, and then we will be returning our value. So first let's get to our base case, and as you can see, when we shift our uh, L pointer m plus 1 to m plus 1, we are directly eliminating half of our array, which will give us like amazing time complexity, and this will help us find any element in an array very easily. So let's go to one of its variation, how we can apply binary search on like we can say reverse array. So we have to, if we have to find 7 in this array, so we will be having our right and left pointer, but uh, if we see above in above example where our array was sorted in no normally sorted, so our L was on the 1, but now our L is on 9 and our R is on 1. So in reverse order, what we will be doing is we will be calculating our M. So as we have our last value and first value is same, it is only in a reverse order, so our mid value will be also on the same. So after that, what we will do is we will check if our middle value is like smaller than our targeted value. As we know, our targeted value was 7, so our middle value is 5, so yes, it's smaller than our targeted value. So what we have to do now is we have to shift our right pointer to m minus 1. In above case, what we have did is we have shifted our L pointer to m plus 1, but in reverse order we have to shift our right pointer to m minus 1, and after that we will again check it, and then again it will be here, and we will get our value. We use three cases in binary search algorithm, so we will be doing it in our example. So now first of all let's understand the question. So what is our question is find a mountain array, find in mountain array. What is mountain array? I will be explaining you with its example. So here is its example. Like here you can see in first array uh, the elements starts from 1 2 3 4 and 5, then it's dipped down to 3 and 1. It's forming an ascending order, then it's getting to a descending order. So basically it's forming something like and mountain, where first we have to climb uphill and then it will go to downhill. So that is it, as it's given in an our question. And then we are restricted to some like extents, like we can only iterate through this array 100 times, and we have to find our value. And also there is other conditions, like we have to use some we have to use some functions which will help us to solve this problem. We can't use any other functions other than this, which is mountain in array dot get dot length and dot get index and all. So to solve this question, let's see how we are going to solve this type of question. So let's get to our approach. So first of all, as you can see, if I demonstrate this example on this array, first let's change this array, make it mountain array. We will make it mountain array. So to make it mountain array, we have to do something like this. 5 is our hill, and after that it's our, like you can see now our array is mountain array. So now you can see from L to M it's sorted array, and from M to R it is also sorted array, but in a reverse order. So now you can understand why I explain a variation of that binary search algorithm to you. So basically we will break this array into two pieces, and then we will search that algorithm, using that algorithm, if our value is there or not. So let's start. First of all, we have to check first of all we have to use our binary search algorithm. So I will take you to our solution. In our solution, what we did is we declared, first of all we counted the length of an array, as we are given some restrictions, and we can use only those function, and those function will only be allowed to solve that kind of problem. So for that we have used length variable, which will count a length of our array. Then I have used L comma R here. As you can see here, I have used L comma R is equal to 1 comma length minus 2. As we know that if we check length minus 1, already length is our array starts from 0th index, so our length will be length minus 1. So for that, so now after that we will use our while loop to understand how our array is. So for that we will use left, mid and right pointers. So I will demonstrate you. So let's understand that if there is, we are using left, mid and right pointer, and we will use, as it is a mid, L will be our left and R will be our right. So okay, we'll take it here, and this will be here. So we will be checking, like if M is greater than L and M is smaller than R, then it will be on ascending order. And if it is like if okay, it's okay now. So if r is smaller than m and m is smaller than l, then it will be on descending order. For that we have to check in our while loop. So we are doing that in our while loop here, and you can check that left is greater than mid is greater than right, then we are shifting our right pointer to mid minus 1, and if it's opposite, then we are shifting our left pointer to mid plus 1. And similarly after that we are using two while loops. In first of all we are doing binary search in ascending order from here till here 5, and we are searching if element is present in between this, and as we get, if we get our element in between this, we are returning our element here, return m. And if there is our element is not present in between our right ascending order, we will be shifting our left pointer here, and like it will be here, and our left pointer should be here. So now we will be checking if it's on our right side, and at every step we are eliminating like half of an array, so it will be so efficient that we will be getting our solution in constraints like in 100 iteration we will surely get our result. And as you can see, I have submitted this solution, and it beats almost 50% of submitted solution, and it beats 90% of solution with memory complexity, so it's a bit optimal. So yes, if we discuss brute force approach, so in brute force approach we don't have to iterate through three pointers mid r and l. We have to just go linearly like 1 2 3 4 5 6 as it goes on. So we have to check our target. Let's suppose our target is 4, so as we get our first occurrence of our element, we will be returning this index. So as it will be solved in this way, and it was not so hard. This problem, a solution may look bit like lengthy, but it's just same code repeating uh, with some variation. And that's it for today's video. Thank you.